Good evening everyone, welcome to BYJU'S exam prep. So I hope my voice and video are absolutely fine. Yes. So this is absolutely fine. That's great. So let's start the session where we are going to discuss the questions based on your communication system, and that is to be based on. Hello Nilima Palia, yes. Good evening. How are you and how are you doing? How is your preparation going on? Yes. So rest of the students can also comment over it. Okay. So before starting the session, this is Saket Verma and I have done MTech from IIT Guwahati and cracked a different PSU exam as well. So the subject which I teach is EMT, communication system. So in the last 3 days, we have gone through some Abhyas series where we solved some questions of EMFT, where we covered the topics from the wave propagation, transmission line, and the antenna. So these three topics we covered, and approximately 7 to 8 questions from each topic we have solved. Now we are bringing one another series which are named as the capsule series. So in this series, we are actually going to solve the questions from the communication. So the topics which we are going to cover is amplitude modulation, angle modulation, and the TCM. Okay, and also I teach the advanced communication systems, signals and systems, and this is my Telegram group. So here you can join me and you can get the PDF of the session, and also you can get the link of the session which I am going to take in future. Okay. So now coming to this part, that we are also bringing one series that is known as the Gate Monsoon series. So this monsoon series, you are going to get the new concepts and the question where you will be able to solve the questions which will be add on to your preparation. Okay, and for this all India rank under 100 rank, if you suppose want, then you can attend this particular workshop which is 7 month strategy, and this is a free workshop and which will be going to held on the 2nd of July. So let's take the first question, and I have to hide myself because I think the question will not be clear. So look at this question. Okay guys, so look at this question and answer this question. Come on. I am also, I'm also going to give you some timer to solve this problem. So what is the answer you are getting, guys? What is the answer you are getting? As you can see that here I am asking for the modulation index. You can, if you see the question directly, then this question is given in this form, that x of am is lambda 1 cos omega ct plus lambda 2 cos omega ct into cos omega xt. Okay, now if I take this lambda 1 cos omega ct common, then I will get 1 upon lambda 2 upon lambda 1 multiplied with cos of omega xt. So whenever the modulation index we want to calculate for the sinusoidal wave, the standard form of the sinusoidal is 1 plus ma cos of omega mt into cos of omega ct. So if you compare the above equation, this is equation number 1 and this is equation number 2. So if you compare the above equation, then you will get the modulation index lambda 2 upon lambda 1. And for the envelope detector, what is the condition? For envelope detector, the condition for the proper detection is the modulation index has to be less than 1. That means this lambda 2 upon lambda 1 has to be less than 1, which will give you the lambda 2 is less than lambda 1. So you have to find the graph where lambda 2 is less than lambda 1. Okay, so this is the point. Suppose this is one point, then you can see that in this region the lambda 2 is greater than lambda 2 is less than lambda 1. Okay, this is a non-linear curve and the lambda 2 is less than lambda 1. Here also this is the lambda 2 is less than lambda 1. But this is the condition of the modulation index, that modulation index can be equal to 1 also. If you want to detect from the envelope detector, then the modulation index can be 1 also. So the lambda 2 can also be equal to lambda 1. So you need a straight line. Okay, you need a straight line and also the region where the lambda 1 is greater. So the correct answer would be option number C. Because there is a non-linear curve here in the option A and this is the linear curve in the option C. So which option will be the correct one? That is the option number C. Now solve this one. Okay, so I think question is visible and also understandable, even though you are not able to see the graph exactly, but the values you will be able to see. So this value is 40, this value 40, 10, minus 10 and 40 are enough to solve this problem. It is not necessary to see the exact graph. Okay, so let's take this question. So as you can see that this is the AM generator, so it will be generating the AM signal, and what will be the expression of YAM. So if I arrange this, so this is nothing but a X, so this is your A carrier amplitude and cos omega CT common and 1 plus the modulation index. Okay, the modulation index, this is for this particular waveform that is given to us, and cos of omega mt, then we are going to get 5 cos omega ct. Okay, now if you multiply this, you will get a cos omega ct plus a into ma cos omega ct into cos omega mt, and then you will get 5 cos omega ct. So you can see that this is a plus 5 cos omega ct and a into ma cos omega ct and cos omega mt. Because the output waveform is also am, so how can you convert it in the standard am expression? So this is nothing but the a plus 5 we have to take common, and ma upon a plus 5, that is cos omega mt, right? यस अगर आप डिप्लोमा के स्टूडेंट हो, 11th-12th की मैथ नहीं पढ़ी है, तो आप 11th-12th के मैथ से ही स्टार्ट करो, स्पेशली लीनियर अलजेब्रा से स्टार्ट करो ना। लीनियर अलजेब्रा वाला जो चैप्टर है वहां से आप स्टार्ट करो, ठीक है। लीनियर अलजेब्रा आप कोई भी स्टैंडर्ड बुक उठा लो, टेक्स्ट बुक, और वहां से आप लीनियर अलजेब्रा से स्टार्ट करो, आपको इजी पड़ेगा। So first of all, what is the value of A? The value of A is nothing but the carrier amplitude. So the carrier amplitude is given as the average value of maximum envelope and minimum envelope. So that is nothing but a 25. So the value of A is 25. Now what is the value of the modulation index? So according to the diagram, the modulation index is 40 minus 10 divided by 40 plus 10. So it is 3 by 5. Okay, so the modulation index also got, the value of A we also got. Now we need to calculate the ratio of the sideband power to the carrier power. So you might be knowing that the sideband power to the carrier power is nothing but the ma square by 2. So whatever will be the modulation index, so the new modulation index whole square divided by 2. So what is the new modulation index? The new modulation index is A into ma upon a plus 5. So this is A into ma upon a plus 5. ma upon a plus 5, that is whole square divided by 2. So this a value of A we have got 25. This is 3 upon 5 divided by 25 plus 5 whole square whole divided by 2. Okay, and this 5 and this 25 will get cancelled. So this is 15 and this is 30. So the value of 15 upon 13 is 1 by 2, 1 by 2 whole square, that is 1 by 4, and that 1 by 2 will also get multiplied. So the ratio of the sideband power to the carrier power is 1 upon 8. How many of you are able to understand this particular problem? Quickly. Anyone? Now coming to the next problem. The signal x of t 1 by 2 cos pi 70t plus 1 by 3 cos 2 pi 120t is input to the square law modulator system shown in figure with a carrier frequency of 10 kHz. Assume V0 is equal to A1 V1 plus A2 V1 square and appropriate bandpass filter is used to generate a standard AM signal. If the output signal has the carrier amplitude 10 volt and the K is equal to 1 by 2, then the value of A1 and A2. So you have to understand that whenever the nonlinear device is given in this form V0 A1 V1 plus A2 V2 square, the value of modulation amplitude sensitivity of the modulator is given by 2 into A2 upon A1. Okay, so the sensitivity of the modulator, that is the nonlinear device, is given as the 2A2 upon A1. First thing. Okay, and as you can see that the value of K is given to as 1 by 2. So this is 2A2 upon A1. So from here you can understand that this A1 is going to be 4A2. So you can put it equation number 1 because we want to calculate the product of A1 and A2. So this A1 is equal to 4A2. Okay. Now what is the expression we get after modulation when we have this type of scheme? So the output AM signal is in the form of A1 into AC 1 plus K into the message signal, which is xt in this question. This is message signal, and cos omega ct. Correct? So this K we have already written. This is 2A2 upon A1. Now what is the carrier amplitude? So after modulation, the output carrier signal has the 10 volt amplitude. So that means it is saying that A1 into AC is 10 volt. When you have performed this complete operation passing through the nonlinear device and filter, you are getting the signal which will have the carrier amplitude as a 10 volt. And what is the carrier amplitude we are getting? The carrier amplitude we are getting as A1 into AC. And when we perform the modulation, the carrier amplitude was AC into cos omega CT, where the AC is equal to 1. So the AC was 1. So that means the A1 is equal to 10 upon AC and the AC is 1. So that is, you have got the value of A1 as 10. So if the A1 is 10, then A2 is 10 upon 4. So that is equal to 2.5. So we wanted to calculate the product A1 and A2. So the product A1 and A2 is nothing but a 10 into 2.5, which is 25. So the answer is 25. Now let's solve one more problem. The beautiful question. Okay, so if you again compare the AM signal which is given to us, it is 1 plus 0.2 into x of t cos omega naught. Okay, so AC 1 plus k into mt cos omega naught t. Okay, then what is the value of k? The value of k is 0.2. The value of k is 0.2, right? Now we want to calculate the power efficiency. And what is the power efficiency? So the power efficiency, that means eta, we know that it is given as k square into m square t bar divided by 1 plus k square and m square t bar. Where this m square t bar is, mean square value of message signal. What do you mean by the mean square value of the message signal? That is the power of the message signal. And how can you calculate the power of the message signal? The power of the message signal is nothing but the mean square value of this particular random variable, because the message signal is defined in terms of random variable. So it is given as b square plus ab plus a square divided by 3. What is the value of b? B is 2. So this is 2 square plus 2 into minus 2 plus minus 2 square. Okay, this is the a. The value of a is minus 2 divided by 3. So this is minus 4, this is plus 4, it will get cancelled. So you will get the value as 4 by 3. Now substitute the value, which is 0.2 whole square multiplied with 4 by 3 divided by 1 plus 0.2 whole square multiplied by 4 by 3. And you can multiply it by 100 if you want to calculate in percentage as per the question. So how much we are getting after solving this? Yes, 5.05%. So after solving this, we are getting 5.05%. So this is the approach to the question. Is it clear to everybody? Now let's solve the other question. We are saying that a double sideband suppressed carrier signal is processed through the block as shown in figure. The message signal x of t is band limited to fx. If the output power p0 is the 1/4 of the input power, then the value of lambda is. See, this is the case of the phase drift. Okay, phase drift in the, or the phase error. You can also write it as the phase drift of, or the phase error. So phase error in the local oscillator. Okay, in the local oscillator of synchronous detector. So if you know the concept of synchronous detector, then this question is very easy for you. So according to that, the output power, when we have got the suppose phase error of theta, okay, suppose this phase error of theta, then the output signal, let us suppose yt, we get is m, it becomes a quadrature null effect. Okay, so the theta is pi by lambda here. So we want to calculate the power. So the output power will be the m square t bar that is the cos square theta divided by 4. Okay, so this is the power, and m square t is nothing but the power of input. So power of input divided by 4 and cos square theta. So it is saying that the output is 1/4 of the input power. So output is 1/4 of the input power, and this is also pi by 4, and we are getting cos square theta. So this pi by 4 and pi by 4 will cancel, and we are getting cos square theta is equal to 1. So theta is equal to pi by 4. Okay, so theta is equal to pi by 4, and we have assumed that the theta is nothing but a pi by lambda. So theta is pi by lambda, and theta is equal to pi by 4 we have calculated. So on comparing, we will get the lambda is equal to 4. So the value of lambda is nothing but a. Now coming to the next one, let's consider single tone modulated AM signal with the amplitude sensitivity of 1/3 volt. Assuming the signal amplitude is 2 volt and the carrier amplitude is AC, suppose the transmission channel completely removes the lower sideband, then the expression of the envelope is. Now when we modulate the single tone sinusoidal signal, we get the expression as AC 1 plus amplitude sensitivity, it is given. So you can write in terms of amplitude sensitivity 1 plus k into mt and cos omega. Signal amplitude is 2 volt, carrier amplitude is AC. Okay, fine. So that's good. Now we know that if I write for the single tone, okay, suppose if I write for the single tone, then we will write k into am cos omega mt, and this is cos omega ct. So if you compare, this is the modulation index you will get. The modulation index is k into am. The modulation amplitude sensitivity is 1/3, and the amplitude of the message signal is 2/2. So this modulation index is 2/3. Now this will become expression as AC 1 plus 2/3 cos omega mt and cos omega ct. Now if I open this bracket, then it is nothing but a cos a plus b omega c plus omega mt and plus cos a minus b, that is omega c minus omega. Okay, this 2 cos a cos b formula I have applied here. Now in this question it is given that it is completely removing the lower sideband. So this lower sideband you have to neglect. So after neglecting the lower sideband, you will get AC cos omega ct plus 1/3 cos omega c plus omega mt. Okay. Now, because we want to calculate the envelope, so again let's write S of t is equal to AC cos omega ct plus 1/3. This is cos A cos B minus sin A sin B, right? We can write like this, cos A plus B. So now if you write the cos term together, so AC 1/3 cos omega mt will be together with the cos omega ct minus 1/3 sin omega mt with the sin omega ct. This is the another term. So what is the envelope here? As you can see that it is written in the quadrature form. So envelope is root over AC plus 1/3 cos omega mt whole square plus 1/3 sin omega mt whole square. Right? So when you will solve it, this is AC square plus 1/9 cos square omega mt plus 2/3 into AC cos omega mt plus 1/9 sin square omega mt. So these two terms, when you add them together, you will get 1. So this is AC square plus 1/9 plus 2/3 AC cos omega ct. So let's see in which form the answer is given. Is it any way to solve it further? 2 by 3 cos omega mt we are getting AC square. Okay, AC is common, I think. Yes, AC is common. So in this question, this is 1 by 9. This AC square should be common too. Yes. I think I have missed the AC in this second part, right? Yes, AC is also there, no? Yes. So this AC by 3 will be left. So AC is actually common. So AC is common in all. So let's write AC is also there. So this AC, and this is also AC is also there. So here also it is AC, and here also it is AC. So when you will solve, this is AC square by 9, and this is also AC square by 9. So you will get AC square by 9. So from here, and this AC square, right? You will get 1 plus 1 by 9. Okay, so 1 plus 1 by 9 in these two terms. That is your 10 by 9. But here we are getting AC square, and this is 2 by 3 AC cos omega CT. So according to this, the AC is common in all. So 10 by 9 is there. So we have got the answer almost, but we are missing something. Yes, okay. So when you multiply this 2AB, then it is also AC square. So this is also AC square. So this is also AC square. Yes. So now the answer we will be getting. This is AC is common now. This is 10 by 9 plus 2 by 3 cos omega CT. Okay. Because when we perform the 2AB formula, then this AC and this AC by 3 cos omega mt will multiply. So this is 2 by 3 AC square cos omega mt. So this is also AC square. So in all the term, AC square is common. So outside the root, this is the AC. So answer is option number C. Correct? How many of you have got this answer? Perfect. Okay. So thank you for watching this session, guys. This is the homework question for all of you. Let's solve this question. This is the simple generic question. Thank you for watching. Let's meet tomorrow with the means on Monday. So next session will be on Monday at the same time 7:30 p.m. That topic will be angle modulation. Okay, angle modulation. So join the session live and we will solve the questions. And don't forget to download our BYJU'S exam prep app, because it is very important, because there are multiple free sessions and strategy session running in the app for free for all of you. And download link is given in this description box. So you can download the app. You can also register yourself in the workshop, and you can also get some scholarship test. So all the links are given in the description. So don't forget to tune with us, subscribe the channel, and also join our Telegram group. Thank you.